Hello, this is Dr. Hanaa Assil, and this is questions and answers on chemical bonding, mainly for the AS chemistry at Excel and the international IGCSE. Let's talk about the questions and their answers. Water reacts with H+ ions to form H3O+ ions. Identify the bonding within the H3O+ ion. Remember that water, this is the dot and cross for water, but remember that we can use a lone pair of electrons on the oxygen to form a bond with the H+. That kind of bond is called a dative bond. So within the hydronium ion, we have normal covalent bonds in which we have a shared pair of electrons. Each electron comes from one of the atoms, and we also have a dative bond in which the two electrons, the lone pair of electrons, two of them on the oxygen are used to make a bond with the H+. That is called a dative covalent bond. Remember, in the hydronium ion, we do not have any ionic bonding. Draw a dot and cross for magnesium chloride. How do we draw dot and cross? Remember, we say magnesium is in group 2. It has 2 electrons in its outermost shell. It needs to lose them. And when it loses them, it becomes 2 positives. Now, these 2 electrons must be accepted by something. We have chlorine atoms. Each chlorine atom has 7 electrons in its outermost shell. So each chlorine atom needs only 1 more electron to have a full outer shell. So we need 2 chlorines to take the 2 electrons that were given up by the magnesium. Of course, do not forget to write the electrons around the chlorine. 7 of them belong to the chlorine and the 8th is the one from the magnesium. And do not forget to write the charges. So the magnesium, when it loses 2 electrons, it becomes 2 positives or +2. Each chlorine accepts only 1 electron, so it has 1 negative charge. Magnesium conducts electricity when it is in the solid state. Magnesium chloride conducts electricity when it is molten or dissolved in water, but not when it is in the solid state. Explain these observations. You should realize magnesium is a metal, and metals conduct electricity whether they are solid or molten. And this is because the metal has free moving delocalized electrons that can conduct electricity. While magnesium chloride, that's an ionic compound made up of positive and negative ions. As a solid, the ions are fixed in a regular crystal lattice. But when molten or solution, then they are free to move. So you should realize that a metal like magnesium has free moving delocalized electrons, while an ionic compound like magnesium chloride has positive and negative ions that are free to move when molten. But when solid, they are fixed in a 3-dimensional crystal lattice, so they're not able to move. The element sodium and the compound sodium bromide are both solid at room temperature. Again, name the type of bonding in sodium and explain how this bonding holds the structure together. Sodium is what? Sodium is a metal. So the type of bonding in a metal is called metallic bonding. So sodium has metallic bonding. Now, how is this bond held together, or how is the structure held together? Remember that in a metal we have strong electrostatic attraction forces between what? If we're talking about a metal, it is between positive ions and the negative delocalized electrons. Remember, a metal is made up of regular rows of positive ions surrounded by a sea of delocalized electrons. So this metallic bond is the strong electrostatic attraction forces between these two particles, the positive ions and negative electrons. Name the type of bonding in sodium bromide and explain how this bonding holds the structure together. So the first thing we're going to think about, what is sodium bromide? Sodium is a metal in group 1, it loses an electron. The Br is in group 7, it gains an electron. That means we're talking about an ionic bond. And remember that the ionic bond, how does this bond hold the structure? It is strong electrostatic attraction forces between positive and negative ions, or we can say oppositely charged ions. The table shows the melting temperatures of sodium and sodium bromide. What can you deduce from these data about the bonding in the two substances? Of course, you should know sodium is a metal, so that's metallic bond. Sodium bromide is an ionic compound. And from the data in the table, obviously, the sodium bromide needs higher temperature to melt, and that means that the ionic bond in sodium bromide is stronger than the metallic bonding in sodium. Name one physical property other than melting or boiling temperature in which sodium and sodium bromide differ due to the difference in their bonding. One other property that is different between sodium and sodium bromide, well, obviously it is the conduction of electricity. You should know that sodium as a metal would conduct electricity when solid and when molten. But sodium bromide is ionic. It would conduct electricity only when molten or in solution, because that is when the positive and negative ions are free to move. The ammonium ion contains covalent bonds and dative covalent bonds. Describe the difference between a covalent bond and a dative covalent bond. Remember, this is ammonia. Ammonia is nitrogen with 3 hydrogens, in which we are sharing 3 pairs of electrons, and in each of these pairs we have 1 electron from the nitrogen, 1 electron from the hydrogen. This is called covalent bond. So in covalent bond, the shared electrons come 1 from each atom. But then if we're trying to make ammonium, how does this make ammonium? The lone pair of electrons left on the nitrogen are used to make a bond with the H+. Now that is a dative bond, because that bond, both electrons that are being shared are coming from only one of the atoms. So both electrons that are being shared for that bond are coming from the nitrogen. So remember that in a covalent bond, the bonding electrons come 1 from each atom, 1 from nitrogen, 1 from hydrogen. While dative covalent bond, both electrons are obtained from the same atom. Draw a dot and cross diagram for an ammonium ion. Again, how did we draw ammonium ion? Well, this is the ammonium ion, in which, remember, we have nitrogen with 4 hydrogens, but 3 of them are normal covalent bonds, so we have 1 X and 1 dot, And then one of the hydrogens is a dative bond with nitrogen, in which both bonding pair of electrons come from the nitrogen, so both of them in this case are dots. Of course, don't forget the overall positive charge. Ammonium ion has an overall positive charge. Explain why the Cl-Cl bond, the length of that bond is 0.199, while the I bond is 0.267. Obviously, the length of the bond between iodine and another iodine seems to be bigger than the length between one chlorine and another. What is bond length? You should realize that bond length is the distance between the two nuclei. So the iodine, the bond length of a Cl-Cl bond is the distance between the nuclei of the two Cls, while the bond length in the iodine is the distance between the nucleus of each of the iodine atoms. And of course, iodine has more shells, larger atomic radius, more shielding, less attraction forces between the nucleus and the bonding pairs of electrons, so they are further away from each other. Which is the shortest covalent bond? Well, let's see. If we're looking at H with H, or H with N, or H with S, or H with Br. Now, H with H, that's two very small atoms. Now, an H with a nitrogen, the bond length will be the length between, or the distance between, the nucleus of the hydrogen and the nucleus of the nitrogen. Nitrogen, of course, is a bigger atom than hydrogen. Sulfur is an even bigger atom. Br is a bigger atom. So remember, as the atom gets bigger, then the distance between one nucleus and the other increases. We're looking for which one is the shortest. So of course, the shortest bond would be the one between the two hydrogen atoms. In the left-hand box, the diagram shows a section of the diamond structure. So when we were drawing diamond, this is the structure of diamond. We were saying it's a giant three-dimensional tetrahedral structure in which each carbon, remember diamond is all made of carbon atoms, each carbon was covalently bonded to 4 other carbon atoms. Then in the right-hand box, label the nitrogen and boron atoms in the diagram of boron nitride. So we have boron with nitrogen. Instead of just having carbon-carbon atoms, we have boron with nitrogen. So of course, you're going to have the nitrogen is the one that can make 4 bonds. So nitrogen making 4 bonds, it would be a tetrahedral like this, and alternating boron, nitrogen, boron, nitrogen. Draw a dot and cross diagram for potassium chloride. How do you draw a dot and cross for potassium chloride? Well, that's easy. Remember that the potassium has 1 electron's outermost shell. It loses that electron, so you can either write the K without any electrons around it, or you can write the fact that once we lost that outer electron, now we have the inner shell is complete, so that is the K plus with the Cl, which has gained the electron from the potassium in addition to its 7 electrons in its outer shell. Again, do not forget to write the charges of each one. Compare the electrical conductivity of potassium metal and potassium chloride. Again, we talked about this. Potassium is a metal. It conducts electricity both when solid or molten. Potassium chloride is ionic, so it conducts electricity only when molten, because that's when the positive and negative ions are free to move. Describe two similarities in the structure and bonding of potassium metal and potassium chloride. So what is similar about potassium metal? Remember we said metals are regular rows of positive ions surrounded by a sea of delocalized electrons. What about potassium chloride? Potassium chloride is giant three-dimensional crystal lattice in which we have alternating positive and negative ions. So what's similar about them? Both of them are held together by strong electrostatic attraction forces between something that's positive and something that's negative. Of course, the metal, its strong electrostatic attraction forces between positive ions and negative electrons. In the ionic, like potassium chloride, its strong electrostatic attraction forces between positive and negative ions. So both of them have positive and negative particles. And in both cases, these are arranged in a regular three-dimensional lattice. So when we say metals have regular rows of positive ions, this is regarded as a regular lattice. The ionic compound has three-dimensional crystal lattice with alternating positive and negative ions. Give one difference between the structures of potassium metal and potassium chloride. Of course, what is the difference? In that the metal has positive ions surrounded by delocalized electrons that are free to move. But the potassium chloride, the ionic compound, has positive and negative ions. Covalent bond length is defined as what? Bond length, we said bond length is what? It is the distance between the two nuclei of the atoms. So which of these is correct? It is the distance from the nucleus of one atom to the nucleus of the other that is called bond length. Draw dot and cross diagram for sulfur dioxide, which shows the sulfur atom with only 8 electrons in its outer energy level. Use dots to represent the oxygen and crosses to represent the sulfur electrons. So how do we do this? Remember, oxygen has 6 electrons of its own. So it needs 2 more. So the oxygen here on the right, or one of them, would share two pairs of electrons, in which we have 2 electrons from the oxygen, 2 electrons from the sulfur. That way the oxygen is complete. Now the oxygen on the left also needs 2 electrons, but then if we use electrons from the oxygen in the bonding, the sulfur will have too many electrons. So remember, one of them will have a dative bond. So the oxygen on the left has a dative bond with the sulfur, in which both bonding electrons are coming from the sulfur. But the oxygen on the right, it has 2 electrons from oxygen, 2 electrons from sulfur. That's a normal double covalent bond. And of course the sulfur has a total of 6, so it has used 2 to bond with the one on the right, 2 to bond with the one on the left. It still has 2 more that has to be put away from the bonding. So these are the 2 X's on top of the sulfur. Then, which of these has a dative covalent bond? Remember, we said dative covalent bond means both bonding electrons come from the same atom. The electrons that are being shared come from the same atom. So ammonia, does ammonia as it is, does it have a dative covalent bond? No. The bonds are all covalent, normal covalent bonds, in which the shared electrons come one from each atom. Hydroxide also has shared electrons, one from oxygen, one from hydrogen. Water, shared electrons, one from oxygen, one from hydrogen. What about hydronium? In order to make the hydronium H3O plus ion, the lone pair of electrons, one of the lone pair of electrons on the oxygen is used to make a dative bond with an H plus, in which both electrons come from the oxygen. So this is the one that has a dative covalent bond. Which of these gives the best evidence that the bonding in copper chloride is ionic? How do we know if something is ionic? Now, remember, the best evidence for showing that bonding is ionic or not is using the electron density map. Remember, electron density map shows contour lines around the atoms. If it is ionic, the contour lines do not overlap. If it is covalent, because there are sharing of electrons, the contour lines would overlap, and this would indicate whether something is ionic or covalent. The melting temperature of sodium is lower than the melting temperature of magnesium. What is the best explanation for this? Remember, when we talk about sodium, magnesium, aluminium, we said the melting temperature increases as the number of delocalized electrons per atom increases. So if we say sodium has lower melting temperature, that is because sodium atoms have one delocalized electron per atom, while the magnesium has two delocalized electrons per atom. So the more the delocalized electrons per atom, the stronger the electrostatic attraction forces, so the higher the melting point. So sodium would have lower melting point. Draw a dot and cross for silicon tetrachloride, showing the outer electrons only. Use X for silicon electrons and dot for chlorine electrons. So this should be the dot and cross diagram that you should draw, in which silicon is in group 4, so it has 4 electrons in its outermost shell. It needs 4 more to have a full outer shell of 8, so it will share one pair of electrons with each of the 4 chlorine atoms. Do not forget to write that each chlorine has still the rest of its 7 electrons. So each of these chlorines will have 1 electron shared with the silicon, and it has 6 more electrons that are away from sharing. Don't draw any more electrons between the silicon and the chlorine. Complete the diagram with dots and crosses to show the outer shell electrons in O2, F2. Again, when we draw dot and cross, we think, let's take a look at the F on top there. Fluorine is in group 7, it has 7 electrons, it needs one more. And that means between each F and O, we're going to have one pair of electrons being shared. Also, the oxygen needs 2, so each oxygen will take 1 from the fluorine and 1 from the neighboring oxygen. So this should be the dot and cross that you would draw for the O2, F2. A pair of electrons being shared between each of the 2 atoms. And remember the rest of the electrons that are around that were not used in sharing. The bonding in solid ammonium chloride is what? Again, ammonium chloride. But here we're not just talking about ammonium, we're talking about ammonium chloride. So you should realize that ammonium chloride between the ammonium and the chloride, it's ionic. Now, inside the ammonium, we said we have normal covalent bonds where we have one electron from nitrogen, one electron from hydrogen, so that's covalent bond. But we also have a dative covalent bond with that hydrogen on top, in which both bonding electrons are from the nitrogen. So actually, when you look at ammonium chloride, there is ionic, covalent, and dative covalent. Draw a dot and cross for strontium chloride. Again, remember, before you draw dot and cross, the first thing you need to ask yourself, is it ionic or covalent? Are they going to share, or one of them is going to lose and the other gain? So, of course, strontium is in group 2, it's a metal. Chlorine is in group 7, it's a non-metal. So, the metal loses, the non-metal gains. Strontium is in group 2, so it's going to lose 2 electrons. Each chlorine atom needs one more to form a chloride ion. So we have 2 chlorines to gain the 2 electrons from the strontium. Draw a dot and cross to show the bonding in nitrogen. How do we draw dot and cross of nitrogen molecule? Molecule means nitrogen with nitrogen. Remember that nitrogen is in group 5. It has 5 electrons in its outermost shell. That means it needs 3. And that means each nitrogen will give 3 and take 3. So they're going to share 3 pairs of electrons between them. But each nitrogen still has 2 more that were left from the 5 that it had. So you need to put that somewhere away from the bond. Draw the dot and cross diagram for ICl3. How do we draw dot and cross for ICl3? Well, I is going to be in the middle with 3 Cl's around it. Remember, iodine is in group 7, so actually it should need just one more. But this is an exception to the octet rule. If you see iodine, it has 7 of its own. If we're going to share one pair of electrons with 3 chlorines, that means that now the iodine has 3 shared electrons with the chlorine, and it still has the rest of its 7, so it still has 4 more electrons somewhere around it. And that means iodine actually now has a total of how many electrons? It has a total of 2, 4, 6, 8, 10 electrons around it. So this is called an exception to the octet rule. Remember, the octet rule says that the atom should have a total of 8 electrons around it. So this is how you draw. Remember, when you draw the dot and cross, you can draw it without circles or you can draw it with circles. Nitrogen can form the following species with hydrogen. Which of these species has a dative covalent bond? Which of these have dative covalent bonds? Again, what do we mean by dative covalent bonds? 2 electrons that are being shared, but both come from the same atom. So remember again, ammonium has a dative bond in which the lone pair of electrons that are left on the nitrogen are used to make a bond with the hydrogen. Draw the electron density map for a chlorine molecule to show covalent bonding. How do we draw electron density maps again? We said chlorine molecule means chlorine with chlorine, and that's a pure covalent bond. So this is how you draw the electron density for a covalent bond. Remember, covalent, the contour lines overlap. Ionic, the contour lines do not overlap. And we have where we have ion polarization, or we say it has some covalent character, when the positive ion is small and the negative ion is large, then the electron cloud on the negative ion is drawn towards the positive ion. That is called ion polarization or partial covalent character. Sodium chloride is ionically bonded. What is meant by ionic bond? What do we mean by ionic bond? Please do not say it's a bond between metal and non-metal. Please. That's not definition of ionic bond. We say the ionic bond is what? It is the electrostatic attraction forces between positive and negative ions or between oppositely charged ions. Remember we said an ionic compound is a giant three-dimensional structure of alternating positive and negative ions. But here we're asking what is the ionic bond. Remember, a bond is always electrostatic attraction forces between something. So in the ionic compound, the ionic bond is electrostatic attraction forces between positive and negative ions or oppositely charged ions. Chlorine gains an electron when it reacts with sodium to form sodium chloride. Draw the dot and cross of what? Please practice that you should read the question and answer according to what the question requires. So here the question says, draw the dot and cross diagram of what? Of a chloride, not sodium chloride, chloride ion alone. So that's what we're required to draw. Remember, a chloride ion is chlorine with its 7 electrons plus an extra electron that it took from the sodium. And it has an overall negative charge. Please do not draw sodium chloride for a question like this. So read the question and answer according to what the question requires. Give the formula of an ion from period 3 that is isoelectronic with chloride ion. Again, what do we mean by isoelectronic? We said isoelectronic means same number of electrons. How many electrons in the chloride ion? Remember, chlorine originally has 17, so when it forms a chloride ion, it gains an electron, becomes 18. So the question wants a formula of an ion in the same period that has 18 electrons. Remember that any non-metal, so phosphorus or sulfur, would like to gain electrons and become the noble gas configuration. So when we form the ion of phosphorus, phosphorus has 15, it gains 3 electrons to have 18. So it is P3 minus. Or sulfur, when it gains 2 electrons, again it's going to have 18 electrons. Ozone. Ozone is a non-linear molecule present in the Earth's upper atmosphere. Complete the dot and cross diagram for the ozone molecule. Show outer electrons only. Use dots for the electrons of the left-hand oxygen, cross for the central, and triangles for the oxygen on the right. So remember that oxygen, let's start with the oxygen on the left, for example. It has 6 electrons in its outermost shell and it needs 2. So we can either the one on the right or the one on the left will have 2 pairs of electrons that would share between the oxygen and the oxygen in the middle. So in this case, I put the oxygen on the right sharing 2 pairs of electrons, 1 from each oxygen. But then that means the oxygen in the middle cannot take any more electrons. It already has 4, 5, 6, so it cannot take any more electrons, the central oxygen. So the oxygen on the left will take electrons from the oxygen in the middle, so that's a dative bond, without giving any electrons of its own. So it has 8, and the one in the middle has 8, and the one on the right has 8, so everyone is happy. Okay, we'll stop here for this section and we will continue some more questions on chemical bonding in the next video. Thank you for listening.